Hello everyone, today we'll be solving the problem substring, right? So this was asked in Codeforces round 460 division 2, right? So for the division 2, right? So you can just go through the question. It's very easy. Just 3 lines of the question, right? So this is related to the input output, right? So I'll just summarize the question so that it will be easier for us to solve the problem. Just give me a second, 1 second. So let's see what the question states here, right? So we are given a directed graph with n nodes. So just remember one thing, we are given a directed graph, not the undirected graph, right? So we are given a directed graph with n nodes and m edges, right? So directed graph with m nodes and n edges, right? So when it comes to input output, quite obviously would have been given m and n in the input, right? So not input output, input basically, right? So we are given a directed graph with n nodes and m edges. Each node has a lowercase letter. Each node has what it has? It has lowercase letter. So we have to define a path's value as the maximum frequency of any single letter along that path. So what we need to do here, we have to define a path value as the maximum frequency of any single letter along that path, right? So we have to find the largest possible path value, or we have to print the -1. So again, I'll just repeat this, just listen to this carefully. Define a path's value as the maximum frequency of any single letter along that path. What we need to define? Path's value as the maximum frequency of any single letter along that path, along that particular path. So we have to go with the maximum frequency of any single letter on that path, right? So we have to find the largest possible path value. Largest possible, what we need to find here? Largest possible, this one, path value, right? In simple terms, largest path value, right? So we need to find the largest path value. If it is not possible, then we have to return -1 in that case, right? So, or we have to print -1 if it cannot be, it can be, or if it can be an arbitrarily large, right? So arbitrarily large, right? So the graph contains a cycle that is reachable in any path, right? So in that case we have to return -1, right? So we have to print -1 if it can be arbitrarily large, right? So what we need to find here, we have to find the largest path value. Just remember this one, right? So we have been given n nodes and m edges. Each node has a lowercase letter. We have to define a path's value as the maximum frequency of any single letter along that path. We have to find the largest possible path value. If it is not possible, then we have to return -1, right? So I'll just remove this. Let's come to the input output part. See here again, as I've said, in the input they have given us n and m, right? So this is nothing but n. N is 5 nodes, and this one m, this one is nothing but the m, right? M is nothing but the edges basically, right? So n is nothing but the nodes or vertices. M is nothing but the this one, edges basically. So the output here, this one is nothing but the path they have given, right? So you can just draw the graph. That one also you can do. It will be easier for us to solve the problem if you actually draw the graph, right? So we have to get the adjacency list, right? We have to get the adjacency list. So here in this case, this is nothing but the path. So 1 1 to 2, they have given a directed graph, right? So this is 1 to 3, they have given again, 3 to 4 they have given, and 4 to 5 they have given, right? So I'll just give you this one, 4 to 5, right? So this is the directed graph, right? So this is fine. Now this is nothing but the path they have given, right? So this is fine. Now the output that we need to get here is 3. Same goes with the other inputs as well, or the other examples as well. This is the first example. So I'm just discussing on the input output part, not the entire approach here. So this is just the input output part. So this is directed graph again. So this is nothing but n, nothing but vertices. This is nothing but m, nothing but this one is edges, right? I hope the input output part and the question part is completely clear, man. Let me remove this one entirely. Let's do one thing. As we are completely familiar with the question now, and the input output part, let's discuss the approach followed by the this one complexities, and then let's write the code. As usual, let's discuss the approach first, right? So I have considered the same first example that they have given in the question. This is nothing but the n, or the nodes or the vertices. This is nothing but the edges, or this is nothing but m. I can just write m, right? So this is fine. We have been given 5 nodes, a, b, a, c, a, nothing but, so this is what do we call, basically from 1 to 2, 1 to 3, 3 to 4, and 4 to 5, basically. Right. So this is fine. You can just draw the graph, and I have already shown that one to you. So the letters they have been given here, 1, 2, 3, 4, 5 represents A, B, A, C, A. Right. So this is fine. Now the output that we need to get here is 3. Right. So here we will be going with the dynamic programming along with the topological sorting. Topological sorting, nothing but the Kahan's algorithm. Right. So we'll be going with the Kahan's algorithm here along with the this one dynamic programming main, right? So to solve this, again just remember this, we'll be going with the Kahan's algorithm along with the dynamic programming, right? So let's move on with the step-by-step explanation here. So before moving on, let me tell you one thing. So we have been given n equals 5. Let me come here. N we have been given 5 and m we have been given 4. S is nothing but here, this one, S is nothing but ABA CA string, nothing but the string. So we can map this one in this way. We can just write here accordingly with the question, 1a, 2b, this one, basically, then 3 again A we have, 4 we have C, and 5 we have A, right? So we can just write it in this way, right? Just give me a second, 1 second. So something's wrong with the pen. 1 second. Yeah, 5a, right? So this is fine. 1 2 3 4 5. Here 5 is again A. This is 1, this is 2, this is 3, this is 4, this is 5. We have mapped like this, right? So edges we have been given here. This is nothing but the edges, we know this. We have already discussed this one, 1 to 2, 1 to 3, 3 to 4, 4 to 8. Nothing but in this case, 1 to 2 is nothing but A to B, 1 to 3 is nothing but A to this one. I had represented this one in the form of 1, 2, 3, 4, 5 itself, right? Rather than A, B, A, C, A. So this has to be represented in the A. They have said in the question that it consists of the lowercase letters, right? So just try to represent the same thing in the form of lowercase letters, man, right? So this is fine. Now, yeah, we have 1A, 2B, 3A, 4C, and 5. So this is fine. Now let's do one thing. Um, Let me explain what we'll be doing basically. Then we can go with the example, right? So we will be making use of the topological ordering, nothing but the Kahan's algorithm, as I've said, right? So this is fine. Nothing but if a cycle exists, this one, if a cycle exists, then we have to go with the answer -1. Again, if cycle exists, then we will be returning -1. Cycle should not exist, right? Accordingly with the Kahan's algorithm. Um, right. So we will be maintaining DP of node and character, right? So node is nothing but the lowercase letter character. This one will be DP of node character equals minimum count of character ch on any path that ends at node. You should be knowing the Kahn's algorithm, right? So we'll be initializing dp of I and s of I, nothing but the string of I, that is equal to 1 for every node. For every node, that means the path of the single node I'm speaking of, right? So this is fine. Now let's process nodes in the we have to process the nodes in the topological order. Just listen to this carefully again. We will be processing the nodes in topological order for each edge u to v. So I can just represent in this way, from u to v, and for every character c, and every individual character c, right? So basically what we will be doing here, we will be going with dp of vc, vertices, not v is nothing but vertices. Dp of vc, c individual character is this one. I'll just go with here max of this one, dp of vc itself, dp of vc here. Again, as I've said, dp of uc, uh, because we are processing the nodes in topological order for each edge u to v, right? And for every character c, right? For each edge u to v, and for every character c. This is the important point here, right? So this is fine. U to c, so this will be c equals s of v. Let me go with the ternary operator. If it is true, then we will return 1, else we will return 0. So this is kind of formula that we'll be going with, right? So just remember this one. We'll be going with the same formula. So this is fine. Now answer is nothing but the max overall dp of ic, so maximum of all that we get, right? So that one we will be considering as answer, right? So let's move on with the example part. So let's try to implement the same. Now we will get to know what I have spoken. So I just said it in the form of theory, right? So let's try to implement the same thing in the form of code. You'll get to know what I've said, right? So first thing, so in degree, so when I draw this one, I had drew a this one while explaining the question. I had drew a graph accordingly with the input, right? So accordingly with the input, so basically only one had the in degree 0, right? So only one had in degree 0, nothing but in this case we'll be considering q equals 1. Only one node was having the in degree 0, right? So we'll be considering q equals 1. We'll be pushing that one, right? So we'll push that 1 to the queue. Next, what we will do after pushing 1 to the queue, we will pop 1, right? So we will pop 1 because we have to update 2 and 3. So if you remember the diagram, you can just go to the video where I draw the directed graph, right? So there we had only one node that has in degree 0. So that one we will be considering actually. One we will be considering. We considered 1, 2, 3, 4, 5. One had in degree 0, right? So we will be considering one and we will be popping that one, right? So we'll be popping that one. Next, what we will do, we have to update 2 and 3 because one was going to 2, one was marking 2 and 3, right? So we have to update 2 and 3. So this formula we just included. So this was like this. If I remember 1, 2, the diagram I drew 3, 4, and this one 4 to 5 I drew, right? So this has to be characters basically. A, B, something they have given here. Just give me a second. A, B, A, C, basically in simple terms, right? So just give me a second here. Yeah, now we know. So this one has an in degree 0, right? So this is the only node which is having in degree 0. See here, this one I'm speaking of, right? So this node, we don't have the arrow mark here, right? So directed graph, I have drew this one clearly. So this is not having any in degree, right? So in degree is 0, right? In degree is 0. This is fine. Now this is fine. Yep. For v equals 2, we have to consider we have to update 2 and 3, this one, and we have to update 2 and 3, right? So for v equals 2 means we are going with a vertex 2 and we are going with a vertex 3 here, right? So dp of 2a will be considering and dp of 3a. So again, the formula we have already discussed this one while I said the theory. So I said the same thing. So this one will be max of um, 0, max of 0 comma dp of 1a, uh, dp of 1a, right? So this is dp of 1a is 1, right? So 1, this will be 0 comma 1 plus 0 is nothing but 1, right? Total final answer is 1, right? So and this will be max of 1 comma dp of 1a plus 1, right? So dp of 1a plus, again this one will be 1 comma 1 plus 1 is nothing but 2, max of 1 comma 2 is 2, right? So this is fine, simple. We have got 1 and we have got 2, right? So the values, so we will continue processing this one. We'll continue processing this one, continue processing 3 to update the 4. So dp of 4a becomes 2. So we'll be doing in, this one in the same way, man, right? So we'll get the output 2 basically. When we process 4, we will update 5. To update the 5, dp of 5 is max of this one 1 comma dp of 4a plus 1. So how we are getting this one dp of 4a value, I have written here somewhere. See, dp of 1a value is 1, dp of 2b value is this one 1, dp of 3a is also value 1, this one also value 1. For all this one we have value 1, dp of 1a, 2a, 3a, 4a, 5a, all the things consist of the value 1, right? So this is fine. Now what we will do, so this one for processing 3, just to update the 4. So 3 to 4 means you to be see here, this one dp of 4a becomes basically 2. The same thing, max of 0 something we will be calculating. The same thing goes with here as well, process 4, update of 5. So we'll be going with a dp of 5 0, max of 1 comma dp of 4a, this is 1, 1 plus 1. uh, this one is basically previously we had got the value 2, so that we will be considering. Don't get confused here. See here, dp of 4a, this becomes 2 when we have updated the dp of 4a to 2, right? So here actual value of dp of 4a is 1, For all the things it is 1. We have updated this one by 2. So this becomes 1 comma 2 plus 1, nothing but here in this case 3, 1 comma 3, and we'll be considering actually 3 max, right? So the final answer after processing 4, nothing but after updating the 5, we get the answer 3. So this one, the final answer, we will be returning as the output. Basically we'll be returning this one as the output. See here, the output that we got here is 3. This one we will return this one as the output. Basically the output that we got here is 3, which is equivalent to the output that they have given for the example but within the question, right? So our approach works absolutely correct in this case. As we are completely familiar with the approach, let's move on with the complexities part, right? So now what will be the overall time complexity here? The time complexity would lead to big O of 26 into n plus m. Why it is big of 26 into n plus m, not just n plus m? Because for each edge we will be updating actually, or we have updated 26 character states accordingly with the approach, right? So for each edge we update 26 character states. It can consist of any character, right? So in our case it was ABACA something, input. See here, this one ABACA. Yeah, I have considered the correct one actually. In our case it was ABACA. It can be any characters, right? It can go up to from basically it can be 26 characters, right? It can be any character out of 26 characters. So for each edge we update 26 character states, nothing but the constant 26. So effectively we go of n plus m with a 26 into constant. 26 into constant means we'll be going with 26 into big of n plus m, right? Nothing but it leads to big O of 26 into n plus m. So the time complexity would be big O of n plus m. Basically time complexity would be big O of 26 into n plus m. So which is equivalent to the big O of n plus m, almost equivalent to the big O of n plus m. We can just consider this one big O of n plus m. So the time complexity and the space complexity for the code that we'll be writing in the future would be big O of 26 into n plus m and big O of n plus m respectively. So space complexity big O of n plus m, uh, and basically DP needs n into 26, right? And also we will be going with the adjacency lists and the in degree. So we have discussed the in degree and the, I said during the approach that we'll be going with the adjacency list as well, right? So these two things also we have to keep in mind. So overall space complexity would lead to big O of n plus m1. So now as we are completely familiar with the approach and the complexities part, we are good to write the code. Let's start writing the code. So let's continue with the code now. So yeah, I'll just come to the compiler here. So let's do one thing. First, I'll just go with import java.io. So we'll be going with the fast input and output. So I'll be going with input output dot star. Right. So we'll be making use of the different utilities as well. So I'll be going with java.util.star. So this is fine. Now let me go with the class named main. So I can just consider any name that's relevant to the problem. I'll just go with the main, right? So now let me go with the main method inside the class. So let me remove this. So let's go with throws input output exception, right? So this is fine, man. So now within this method first, let's go with the fast buffered reader, right? So fast input we have already this one we have already what do we call imported the input output package, right? So I'll just go with here buffered reader. So this one br will be equivalent to new buffered reader. This is fine. So this one will be new uh, input stream reader of, so this one will be system.n. So this is fine. Now sorry man, just give me a second here. We'll be going with the this one string tokenizer as well. So I'll just go with string tokenizer. This is fine. St, this is equivalent to new string tokenizer. So this one buffered reader. So we'll be going with a read line. So I have to type, I think, this one entirely. This is function read line. So this is fine. Now we have to go with n m and dis, right? So accordingly with the input, so we had discussed. So this is related to the input output part, right? So this is n, first one, this is m space m, and this is nothing but the string s, right? So I'll just go with here int n. This is string, right? I mean this is integer, right? 5 and 4 they have given. So this one I'll just go with a parse int here. string tokenizer st, this one will be next int. Next, sorry, let's go with the next token as we are dealing with a string tokenizer, right? I'll just go with the st dot next token. This is fine. Now what we'll do, we have to consider m as well, right? So let me consider same one here. Let me copy here, let me paste it over here, right? So this is also fine. Semicolon. Next we have to consider the string s, which consists of a, b, a, c, a in our case first example. So string s equals, so here let me go with star first. This one will be pr dot read line. This is function. So what we are doing here, we are just we just have to read the string of letters and pad with star, right? So this is fine. Now we have to go with the adjacency list for 1 to n, right? As we had discussed in the approach. So I'll just go with list here. So this one will be integer. This is fine. This one will be g equals new. This one will be array list of n plus 1. This is fine. So this is adjacency list for 1 to n. So let's go with the for loop here. This one will be int I equals 1, I less than or equal to n. So this is I plus plus. So this one, let me go with iterated value of the g here in case. Let's go with the instance of the array list here. So we'll be making use of the array list, right? So we are just initializing each adjacency list here. And now we'll be considering in degree as well. So I had showed the in degree part to you clearly in the approach. So I'll just go with here in degree. So this one new int of, let me go with n plus 1. Let me go with n plus 1. So this is nothing but the in degree array. In degree of I equals number of the incoming edges to the I. So this one I have showed. So this one you have to be knowing. So whenever we are solving the dynamic programming or the graph problem, you have to know certain things. You have to know graph, you have to know in degree, out degree, you have to know adjacency list, adjacency matrix. These are the topics you have to know at any cost, right? And certain algorithms as well, whether it may be Kahn's algorithm related to the topological sorting, Dijkstra's, and there are so many algorithms, man. You have to know. And when it comes to DP, bottom up approach, you need to know, right? Top down, you need to know. There are certain things. What is DP table? So every time we take the last this one last element in the table, right? So as the answer, so you need to know about the dynamic programming. So you have to know about the caching first, mainly, right? Memoizing, right? So these are the things that you have to know at any cost before solving the graph or the DP, right? So this is fine. Now we have went with the integer array. This is fine. We have to read m edges, right? First, so m we have been given 5 in our case, the first example that we considered. First, we have to read all the m edges. So let's go with the iteration part. So this one will be I equals 0, I less than m, I plus plus. So within the for loop, what I'll do, string tokenizer st. So this one new, this one string tokenizer. So this one buffered reader dot read line. So this is fine. Next, let we have to go with the u and v as we had considered, right? So this one will be int u equals integer dot percent. So this is fine. This one has to be capital I. Where have I used the percent? Somewhere I have used the this one small I. Yeah, here in the suggestions it is showing. This is fine. Anywhere percent. So here as well. This has to be capital I, man. Uh, this is fine. Percent of string tokenizer dot. We are making use of the next token function. So this is fine. For v also we'll do the same thing. So I'll just go with integer. So let me copy this one and let me paste it over here. Right. So what we are doing here, basically, just give me a second here. Did I miss anything here? Did I miss anything? 1 second, man. Just give me a second here. So yeah, we are just parsing the edge here from u to v basically. that's what we are doing. I don't think I have missed something. Why am I feeling like I missed something? No, right? So this is fine, man. Let's do one thing. Let's move on with the further steps. Let's add the v to the adjacency list of u and let's increment the in degree of v. Right? So in our case, we had only one vertex with a in degree 0. Right? So that one itself, we have to add that one to the queue and pop. Right? So first, let's add v to the adjacency list of u and increment the in degree of v. So before getting into that part, so this one will be g of u dot add of v. This is fine. In degree of v, let me increment this one as well. So this is fine. Let me come out of this one entirely. Now let's go with the main DP part. Nothing but DP of IC, that is equivalent to the maximum count of character C on any path, right? So this we have discussed on the approach itself. So I'll just go with here DP equals new int of this one will be n plus 1. This is fine, and we have 26 characters. I'll just consider 26 here. This is fine. Now as we have to go with the queue, we have to add the vertex with the in degree 0 first, and then we need to pop, right? So queue here, this one basically it consists of the integer, right? So let me go with the integer here. This is fine. I'll just consider the variable q. This will be array. I'll just consider dq. So this is faster, right? You. So this is fine. This is just the syntax part, man. Now let's do one thing. Let's move on with the iteration part. Means let's initialize the DP and collect the 0 in degree nodes. So here in this case, for this one will be int I equals 1, I less than or equal to n. So this one will be I plus plus. Uh, Again, let's go with a single node path that is ending at I that contributes one occurrence. So here this will be dp of I s dot. I'll just go with a char it here. So this one has to be I, right? So hyphen hyphen a. Nothing but we are just going with a single node path that is ending at I contributes. That I contributes one occurrence. So this is fine. We know this from the what do we call this one? We have to assign this one to one, right? So we that contributes to one occurrence, as I've said. So single node path ending at I that contributes to one occurrence we have to consider, right? So this is fine, man. Next, if node has in degree 0, then we have to add that one to the queue, right? To start this one topological. This one, what do we call that one? So I don't know how to say that one. Just give me a second here. 1 second. Uh, Topological processing. So I think so. So here, what we are doing here, if node has in degree 0, then we were adding that one to the queue, if you remember, right? In the approach, just to start the topological processing, right? So here, let me write that one using simple if condition. So this one will be in degree. We have already considered I and deg. So this one, if it is equal to value 0, then we shall add that one to the queue. Q dot add of I, right? So this is fine. So now we are done with this part. Let me come out of this for loop entirely, right? So this is fine. Now let's do one thing. We have to go with initially let's initialize scene and as well as the answer. Scene is nothing but the number of processed nodes, all the nodes that we have processed, and this one answer is nothing but the answer to compute. Basically we need to compute the answer, right? So I'll just go with scene equals 0 and answer or result, anything you can consider. I'll just go with ans here. This is fine. So pure this one, we are just going with a queue here. Months basically BFS. This one will be we have to process the nodes in topological order, right? So this one has to be q dot is empty. This is fine. Now within this one, within the while loop, for every outgoing edge u to v we need to consider, right? So first let me go with the uh, initialization of u. So this one will be q dot pole. and let me increment C in here, right? So let me increment C in here. So this one poll function. So this is fine. Now here basically we are just popping one node u and incrementing the process count. Next we have to consider for every outgoing edge u to v, right? So for every outgoing edge u to v means we have to go with the iteration part, right? So here in this case this one will be int v of crap basically g. We have considered variable g u. So within this for loop, let's do one thing. Let's consider one more for loop. So this is nothing but for every character C means it can consist of 26 lowercase letters, right? Either from A to Z. It can consist of any letter. So I'll just go with for this one will be int C equals 0, C uh, less than 26 and C plus plus. So this is also fine, man. Now, dp of v and c, this one, let me assign this one to a kind of formula we wrote. If you remember, math dot max, this one I had explained in the this one, what do you call, approach. So this one will be dp of v c, the same thing we'll be going with, comma dp of u c, and here it will be plus if the value of c is equivalent to string dot caret this one v at v basically in simple terms, right? See this one v hyphen a. We are going with the strings, right? So this one has to be a in this way, a then if you remember, if it is true then we have to display 1 else 0. This is fine. So we are done with this part. Next, we have to decrement the integer of v if it becomes 0, right? So we have to decrement the integer of v if it becomes 0, then we have to push v to the q. So previous line, this one basically line number 32, what we did here, we are just going with a transition here. We are just extending the path ending at u to v, right? So now in this line 33, what we have to write now, we have to decrement the in degree of v if it becomes 0, then we have to push v to u, right? So here in this case I'll just go with if in degree of v this is equal to value 0, then I'll just go with a q dot add of v. So this is fine. Now let me come out of this one entire lemon. So we are left with a few steps now. If the nodes are not at all processed, means if a cycle is formed or if cycle exists, then the answer is -1. We know that they have strictly mentioned in the question. If cycle is formed or if nodes cannot be processed at all, then we have to return -1. Let's do that. This is important as well, right? So if seen not equal to n, then if nodes are not processed, so I'll just go with here system out println, we need to return -1, right? So we need to return -1, then we don't have to return any value, right? So I'll just go with return man. So this is also fine. mm, yep, let me come out of this entirely if condition. Next let's go with a two iterations. Nothing but we have to iterate all the nodes, also we have to iterate all the characters, right? So let's go with two for loops here. First let's iterate all the nodes here. This one will be int I equals 1, so I less than or equal to n I plus plus. So this is fine. Now again one more for loop. So this one will be for the character c equals 0, c less than 26, uh, 0 to 26, right? So 0 to 25 basically, because we are starting with a 0 indexing. So this is fine. C plus plus. So within this for loop, we are iterating all nodes and all characters. Now we have to take the maximum DP value over all the node character pairs. That's what we need to do here, right? So let's see how can we articulate the same thing in the form of code. So this one will be answer equals math dot max of this one answer, comma dp of I and c. This is fine. We are just taking the maximum dp value. finally we are left with the last step, nothing but we have to print the final answer. That is stored in the ans variable. So whatever we have considered. So this one I'll just go with the system out println. So I'll just pass ns variable here. Simple, right? So what we did here basically, whatever we discussed in the approach, the exact same thing we have articulated in the form of Codeman, right? So here I did a mistake, I guess. Uh, so this one has to be 1 second. Oh, this is insane. This one and TP is fine. Scene equals arrow. This is fine. Mm, and now here, after this one, let me place this one here. So this is bracket. I have misplaced the braces actually here. So this is fine. Now one more place I have misplaced the braces. I don't know where. So this is fine. Just give me a second here. To when degree equals 0, we are just adding that one to the q, right? So this one is v. Uh, so this is not this one. So this is fine. We are going with this one, right? Here q. This is fine. If integrity of I equals 0, if node has integrity 0, we are just adding this one to the q somewhere. This is fine. So I have considered here. Let's see, man. This is fine. Let's do one thing. Before testing this one, before testing the code with different inputs, I just want to copy paste the signature starter template. Just give me a second here. So I'll just come here. So here you can clearly see, right? Uh, this one. Let's move on with the logical part. So let me copy this one. Hope we don't get any error. We run this one. We have a lot of errors. So this one has to be buffer data dot read line. So this one line number 27. This one has to be br dot read line. Uh, buffer data dot read line. So this is fine. One error is gone. 9 errors we have. Again, error, not a statement. U dot add line number 35. We have this one vertex. U to V we are going with, right? So this one, just give me a second here. So here we have there. Oh, this has to be parenthesis one. This is not the array basically. Line number 35, right? So I'll just go with the 35. Where is it? So this one has to be parenthesis, not the array. So now this is fine. Next, let me run this one. We are left with 8 errors. This is fine. Uh, this is fine. Of integer. So this one here. So yeah, this one I have given. So this one I have mentioned this one dq or deque, just deque, right? So let me run this one again. So we are left with the same thing basically. Just give me a second here. So let me come here. So this one has to be not s dot char of v. This one has to be s of char at basically, right? So now this is correct. So let me run this one again. So yeah, 4 errors are gone. So we are left with 4 more errors, right? So let's see line number 61. Where is it? Point I equals 1, I less than or equal to I plus plus. What is wrong here? Basically, system out println answer. So this is fine, right? What mistake we are doing here? This is fine. 1 second. Just give me a second here. So I think we have misplaced the bracket. So this one, let me do one thing. Uh, this one, let me cut here. So let me paste it over here itself. So let me copy this one. Let me try this one after this one. So let's see whether we get the output or not. So we are getting the warning, but we are getting the correct output, right? So yeah, this works correctly. So we are getting the output 3. So let's ignore the warning for now. So let me copy this one. We have to get answer -1. Let's check the same here. So if I run this one, we are getting the -1. This is fine. The final answer, we have to get 4 for the final input. Yeah, we are getting the 4. Means this works absolutely correct, right? So this is fine. So brackets was the main thing here. This one. I had misplaced the brackets and some typos here. This has to be char it, not just char. And yeah, for v instead of this one parenthesis, I had mentioned square brackets, right? So that was one thing. So this is fine. Now let me come here. Mm, let me hit the submit button. Let's wait for some time. So let me paste the code here and let me hit the submit button. I hope this works for all the test cases, man. Let's see. So let's wait for some time. I hope this works. Let's see. Let's wait for some time. Hang on, test one. Let's wait for some time. So yeah, now this is considering actually running on test 2. This is slow, man. Yeah, now this is fast, right? It's fine. Yeah, you can clearly see here in the toast it is showing accepted, right? So the verdict that we got here is accepted, right? So we have went with pure this thing, Kahan's algorithm along with the DP, right? Nothing but the topological sorting. Along with the topological sorting, we have went with a DP, right? So mainly, right? So this is the uh, approach basically, right? So this is fine. I hope the solution part is completely clear along with the approach and the complexities part. For now, this is it. Thanks for watching, guys.